right, today we're going to look at exponential growth and how to write an exponential function based on a table. So in my first table here, I actually have a linear function, and I'm going to use this to kind of model the thinking that we go through when we're looking at a table. So in my table, the first thing I typically do is I say, okay, well, how is this thing changing in my y, and how is it changing in my x? So when I look at my y, let's see, I'm going up 2 here, I add 2 here, I add 2 here, I add 2 here. Awesome. And then I look at my x and I say, okay, I'm going up 1 here, up 1 here. Perfect. Up 1 on each of them. So in a linear function, we have y equals mx plus b. So our m value is our change in y, which was 2, over our change in x, which is 1. So, or we simplify that to just 2. So we're going to say y equals 2x, and then my b value comes from when x is 0. So when x is 0, my y is 5, so I say plus 5. And that's pretty straightforward. So when I get down here to the second table, we're going to write this. This one's going to be an exponential growth. And we may not know that just by looking at the table, but the formula that we're going to use, or the outline we're going to use here, is y equals a to the b times x. So I'm going to start this the same way I started the other one, and I'm going to say, okay, how is my y changing? So when I look here, this goes up 3, and then here it goes up 12, and then here it goes up 48. Okay, clearly this is not changing by the same amount. So sometimes you can look at what they call the second difference and see how it's changing on the next one. Well, let's see, this would be going up 9, and this would be going up 36. Okay, so clearly this is not consistent. So this is not a linear or a quadratic function based on that. So I'm going to go back and I'm going to say, well, let's look at this a different way. Instead of looking at how it's increasing by adding, I can also increase something by multiplying. So maybe I'm multiplying each value by something. So to go from 1 to 4, it would be times 4. From 4 to 16 would be times 4. From 16 to 64 is times 4, and 64 to 256 is also times 4. And again, I check my x values, and I can see that they're still increasing by 1 each time. So when we look at this formula that we're going to use here, the b value is going to be your growth factor, okay? So it's like your base. So in our problem, it's going to be your growth factor. And our growth factor is going to come from this number here, which is how my problem is growing based on multiplication. So I'm going to have y equals something times 4 to the x power. Now the something that we're being multiplied by, that a value is actually your initial amount. So I'm going to change colors here real quick for the a value. The a value, you're going to go back to your table and you're going to look and see when x is 0, what is y? In this case, it's 1. So I would say I have 1 times 4 to the x, which I can just write as 4 to the power of x. Let's practice this again on this second problem here. So in this problem here, again, if I look at this in terms of how it's changing, I can see that this one is times 3. Let's see, 15 to 45 is also times 3. Times 3 there, and then finally times 3. Okay, so in working with my a, b to the x, the b value, which represents our growth factor, is going to come from how this is changing here. And again, I do want to check and make sure that my x values are changing by 1, which they are. So I'm going to have y equals something times 3 to the power of x. I'm going to look to my table, and I'm going to say, okay, when x is 0, what is y? It's 5, so that's going to be my initial amount, which is my a. So I'm taking 5 times 3 to the power of x. So if I want to check this, I can look at my values and see. So 3 to the power of 0 is 1, times 5 is 5. Then if I go to the next set where x is 1, 3 to the power of 1 is 3, times 5 is 15. If I go to the next value, 3 squared is 9, 9 times 5 is 45, and you will see that it works all the way through. One last example to look at here. Again, we're using y equals a times b to the x. I'm going to try to see if I can figure out how my y value is changing. So it looks like I'm doing times 2 each time. It's doubling. My x value is increasing by 1. So I know that my base here, my growth factor is going to be 2 based on how this is growing. So y equals something times 2 to the x power. I go into my table and I say, okay, when x is 0, what is y? It was 3, so I'm going to substitute in a 3 there, so I have 3 times 2 to the power of x. And again, if you want to check that, you can. You can go across your table and try some values. So when x is 2, 2 squared is 4, 4 times 3 is 12. That works. If I go to where x is 3, 2 to the third power is 8, 8 times 3 is 24, and I can see that that works as well. I hope this has been helpful.